Hey everyone, my name's Will Robinson and I'm joined by my colleague Dom Biddlecombe.
Hello, Will. How are you today?
Good, thanks Dom, how are you?
Very well, thank you.
That's good. We're a couple of senior sales engineers for Trem Micro. I'm based in Melbourne and Dom is based in Sydney. And today we'll be doing a talk on end-to-end container security. So let's get started. So what we'll do is I'll lead with some frequently asked questions and answers that were typically asked by customers when it comes to containerization and the like. And then what I'll do is hand over to Dom, who will give us a hands-on demo of how Trem Micro can assist customers in protecting their containerized environments. Okay, so first up, the first common question that we're asked by customers are, why should we containerize? We've got on-prem servers, we've got cloud servers, virtual servers, and now you're asking us to containerize as well. And look, it's a very valid question. The reason why we suggest customers start looking to adopt containerization is because it is safer by default. The reason being that containers are much smaller than our traditional on-prem or virtualized servers. Because with containerization, what we have are very small operating systems. So instead of a large bloated CentOS or Ubuntu or Windows server, what we have instead is a very small something like an Alpine Linux operating system, for example. So we're going from operating systems which are a couple of gig down to a couple of hundred meg, for example. And the beauty of that is because with that smaller operating system or that smaller code base, we're reducing our attack surface. Furthermore, these operating systems often have nothing enabled by default. Again, we've got less services enabled and therefore we're reducing our attack surface. So the short of it is that we're reducing our attack surface by having smaller code and smaller things running on that operating system. The next question that we're typically asked is, where are these containers hosted? The good news is they're hosted wherever you'd like to host them. If you have an air-gapped environment, a virtualized environment, if you've got a multi-cloud strategy, you can host containers anywhere and everywhere that you like. The beautiful thing about containers is that they're portable. So that same container that is running on-prem can just as easily run in GCP, AWS, Azure, wherever you like, with no modification required at all. So how do we run them? There's two primary ways that we can run our containers. We can run them through Docker, where we install an executable on our host, or we can use something like Kubernetes, which is known as a Docker orchestrator, a container orchestrator. The beauty of a container orchestrator is that it enables us to set up auto scaling and the like, and load balancing deployments and Helm charts and the like, which is probably a little bit too deep in for this type of conversation, but it is good to be aware that container orchestrators do exist. Again, if you are new to your containerized journey, I would highly recommend something like Docker on your on-prem hosts or something like Fargate for your AWS or cloud-based infrastructure. So how are they more secure? As I touched on before, with containers, we have that smaller footprint. And furthermore, we only enable the services that we require for those containers. So what are the unique challenges for containers? I mean, as they say, you can't get something for nothing. Well, yes, with containers, because they typically are different operating systems and they're typically running in different environments, such as Fargate, for example, where we don't have access to the underlying operating system, our traditional agent-based security may or may not be able to protect these containerized environments. And therefore, we may need to look at something like application security by Trem Micro, or even workload security that is able to give us that single pane of glass that protects our on-prem servers as well as our containerized environments through that single pane of glass or that single panel. Finally, how do we enhance security of our containers? I mean, yes, they are secure by default or mostly secure by default. And yes, we do have that less code running within the containers. However, we do want to enhance their security. So to answer this question, I'll hand it over to Dom, who will take us through how workload security by Trem Micro is able to protect our containerized environments. Over to you, Dom.
Thank you, Will, and thank you for that. So guys, what I'm going to be talking about today is runtime protection, runtime security within your containers running on your host operating systems, and demonstrating a vulnerability which has been in the news and was in the news because of the amount and how big it was, and really just showing that a simple vulnerability, if exploited, can affect and negatively affect a whole bunch of people. So the vulnerability I'm referring to was the Apache Struts vulnerability, which affected a credit ratings agency, Equifax. And really what happened here is remote attackers were able to arbitrarily run commands on vulnerable systems without authenticating to those systems, otherwise known as a remote command execution vulnerability. And what they were able to do is from Equifax, able to steal over 140 million user records out of the Equifax backend. And really, this was just due to a vulnerable Apache Struts environment. It hadn't been patched, unbeknownst to Equifax. Perhaps they hadn't had time to patch it. Maybe, it was just one of those things they were getting to, or maybe they didn't even know about it. But someone snuck in, stole these records, and really goes to show that a single vulnerability can lead to wide-scale loss of information and sensitive information at that. So what I'll show today is this particular vulnerability running, how it's exploited, and then importantly, what we can do to mitigate it if you are running something like workload security from Trend Micro. So we go ahead and share my screen. What I've got is I've got a Amazon Linux 2 server running in AWS. And what I've done with the server is I've installed an agent on it. I've enabled the anti-malware module. I've enabled the IPS module. And the IPS module is going to run the requisite recommendation scan. And the recommendation scan is going to be able to add the rule sets needed to protect any vulnerabilities which may exist on the system by way of a virtual patch. So virtual patching is a method of protecting and shielding vulnerabilities which may exist on your servers by way of missing vendor patches by installing IPS rule sets, which will interrogate, intercept the rules, look for those malicious payloads, and if found, will stop them at the IPS layer without you having to necessarily install or update your servers. The same method will extend to any running Docker containers which may be running on your Linux hosts. So this particular server, as I mentioned, is running Amazon Linux 2. However, it's also running Docker. And as part of the installation of the agent, that same agent is able to detect and protect any running Docker engines and containers which may exist on this host. So what I'm going to do is I'm going to jump over to my environment. On the left-hand side, what I have is I have an attack system where I'm going to be running the exploit from. And on the right-hand side, I have my Linux host, which you saw in the workload security console. And this particular host also has Docker running. So if I have a look at the containers that are running on here, let's have a look there. Docker container. Oops, let me do that in lowercase. What I've got is I've got a Struts container running. It isn't up and running at the moment. It is just installed. And what I'm going to do is I'm going to go ahead and start this particular container. Right, let's go ahead and do that. And that process is going to now expose a TCP port 8080 to the outside world. And if you think about this from the point of view of Equifax, this is kind of the method that an external attacker would have taken. There would have been an Apache Struts environment running. It would have had an exposed port, and someone would have then found this vulnerability and exploited it by coming in through that exposed port to the internet. And so I'm going to run this exact same method. So we've got port 8080 open on the victim IP address. And what I'm going to do on this side is I'm going to run a Python script, which I actually downloaded off the internet. The point being that this is freely available, anyone can get it, and it certainly doesn't require any coding or even particular technical abilities to be able to download this, read an article, watch a YouTube video to be able to try and exploit these things on the internet. And so anyone can essentially be a hacker these days by way of this freely available exploit code. So what I'm going to do is I'm going to run my particular vulnerability. And the way I do that is I use Python. I run it against my particular file, which I downloaded off the internet. In other words, my exploit code. I specify the victim's server's IP address, the main IP address of the Linux host, and then, of course, the exposed Docker port. And what I'm going to do is I'm going to run a command which is going to hopefully show me all of root's hidden files in the root directory. And normally and ordinarily, I would require some sort of authentication to be able to do this. I would require root privileges. However, bear in mind, I have none of that right now, and all I'm doing is running Python with my particular exploit code. Let's go ahead and do that. And as you can see, that succeeded very, very quickly. And I'm able to see all of the files which exist in root's directory. Not only the normal files, but these are in fact the hidden files. And let's go and have a look at which credentials I'm using. Let's run who am I. And as you can see, all of these commands that I'm running on the victim server are run as root. So that's showing you really that this particular vulnerability is able to become the root user and run any commands on the victim server as the root user without any authentication whatsoever. And so, that really is a scary fact. And unfortunately, we see a lot of similar attacks, a lot of similar exploits. In the Windows world, we've just had zero logon, and we're still kind of in the throes of that, but very similar MO when it comes to what's been exploited and how attackers are able to leverage exploits and elevate their privileges and essentially assume control of the victim servers. So bear in mind, what we had initially is we had 13 rules which were implemented as part of the initial recommendation scan without the running container. In other words, that vulnerable environment wasn't yet present when we ran the initial recommendation scan. And so what I'm going to do now is I'm going to go ahead and run an ad hoc recommendation scan to now encompass this new environment, i.e. the vulnerable Apache Struts environment. Bear in mind, initially there were 13 rules, and we would expect this rule count to increase. And as you can see very quickly, it's now at 42. So 42 rules are now in place, and that's 29 in addition to the original 13, which means that just the presence of a vulnerable struts container has added automatically and implemented automatically the additional rules to now cope with any vulnerabilities and issues which may exist within this new environment. So let's go down and have a look at all of the different rules. And importantly, what we're seeing is a whole bunch of rules relating to Apache Struts now. So the container's running, it is vulnerable. And so based on that, the recommendation scan has been able to run, identify this, and then automatically add additional rules to then block any exploits which may be launched against this newly started vulnerable environment. So let's go ahead and go back to our original code that we ran to try and exploit this vulnerability. So let's go ahead and run it. Same method, exactly the same command, but now what's happened is we get a connection reset by peer. So even though the environment on the right-hand side still remains vulnerable, in other words, we haven't gone ahead, we haven't updated the software, we haven't installed new versions, is as vulnerable as it was 5 minutes ago. However, given the fact that we now have the additional IPS rules that are now able to inspect the traffic, look for that particular payload, and if found, take action on it. So let's have a look at the IPS events. And as we can see over here, one event was picked up. It has been picked up because a particular rule was triggered. That was the Apache Struts expression remote command execution vulnerability. And obviously that's what we try to exploit, to run these remote commands on the Apache Struts environments. And the action taken against this particular exploit or this particular attempt has been reset. So by simply running a recommendation scan, it gives yourself really an environment where even though it may still be vulnerable, you have time to plan updates, to patch your systems when it suits you, all in the while knowing that you are protected, that you can kind of still continue to run your systems and your operating systems and your containers for that matter with vulnerable code, and making sure that the virtual patching takes care of the mitigation of any exploits against it. So I really want to show that to you guys, and I hope that was useful. We kind of pride ourselves on the fact that we protect not only current operating systems. Our virtual patching still protects a whole raft of legacy operating systems, both on Linux and on Windows, and can really be a fantastic mitigator if you do have systems that may be missing patches and that you haven't got around to patching. You may be planning your patching sometime in the future. This method can certainly step in and provide the assurance that you can still continue to function in a production environment just by running the virtual patching. Thank you guys for your time today. Will, is there anything else from you?
No, that's great, Dom. As Dom has shown us, and as he just covered off, workload security, again, containerized, bare metal, virtualized, all through the single pane of glass we've seen today. But yeah, look, thanks for your time, Dom, and thank you to the audience.
Thank you, guys. Have a great day further.